You are born into a world without addresses. No house that your family has owned for generations. No fields, no fences, no livestock pens, no supermarkets, no money to buy food. When one resource runs out, you move. When the season changes, you move. When the herds leave, you may follow them. When an area no longer provides enough food, you look somewhere else. This is not a life of aimless wandering. Hunter-gatherers can possess extraordinarily detailed knowledge of the landscape. They know the water sources. They know when fruits ripen. They know where animals pass. They know when the fish appear. They know which valleys are dangerous. They know the way back. Their world has no streets. But that doesn't mean it has no map. The map exists in memory. And this system worked for a length of time that is almost impossible to imagine. Homo sapiens has existed for around 300,000 years. Agriculture appeared very late in that story. For most of our species' history, we lived through hunting, gathering, fishing, and many different strategies for exploiting wild foods. And clearly, it worked. If it hadn't, we wouldn't be here. So imagine a morning more than 10,000 years ago. You're holding a handful of seeds. You could eat them. But instead, some are kept, then placed into the ground. You don't know this yet. But that seemingly small action will help change everything. Where you live, what you eat, how many children a community can support, the diseases you encounter, how humans own land, how wealth accumulates, how wars are fought, how rulers emerge, and thousands of years later, it will help create cities containing millions of people. But there's a problem. Why would you start? Why abandon a flexible system that had worked for hundreds of thousands of years to place your life in crops that could die in a drought? Why spend hours working on one piece of land when before you could exploit many different food sources? Why create a life that forces you to stay instead of leaving when the environment becomes bad? For decades, the story of agriculture was often told as if it were an obvious invention. Humans became smarter. They discovered farming. They realized it was better. Then they settled down. But archaeological evidence suggests that the real story is far more complicated. Agriculture didn't appear only once. It wasn't invented by a single genius, and it didn't spread simply because it immediately made everyone healthier or gave them more leisure time. The process of domestication occurred independently in multiple regions of the world, with different species, and through different pathways. And in many cases, the boundary between foraging and farming wasn't a straight line. Humans could manage wild plants, harvest selectively, burn landscapes, protect certain species, tend, and then across many generations, the relationship between humans and plants changed. There was no morning when humanity woke up and said, "Today we're going to invent agriculture." What happened may have looked more like this. A small behavior proves useful, so it is repeated. Then it becomes a habit. Then the habit begins changing the environment, and eventually, the environment changes humans in return. But to understand why this process accelerated after the Ice Age, we have to begin with an event no human being could control. The climate changed. A new planet appeared beneath human feet around 12,000 years ago. The Pleistocene was coming to an end. Massive ice sheets retreated. Global temperatures changed. Sea levels rose. Ecosystems shifted. Regions that had once been cold and dry began to transform. Plants expanded into some areas. Animals changed their ranges. And humans had to adapt. But we need to be careful. We cannot simply say the Ice Age ended humans' invented farming. If climate automatically created agriculture, every community in the world would have become farmers at the same time. That didn't happen. Many communities continued hunting and gathering for thousands of years. Some maintained those ways of life until periods very close to the modern era. So climate is only part of the story, but it changed the board on which the game was being played. In the Fertile Crescent of Southwest Asia, some human groups were exploiting wild cereals such as wheat and barley before those plants became fully domesticated. Imagine standing before a grassland filled with grain. You don't have to chase it. It doesn't run. It doesn't fight back. It has no fangs. It simply stands there. You harvest it. one person can collect a significant quantity of grain. And grain has another special advantage. It can be stored. Meat is an excellent source of energy, but it can be difficult to keep for long without processing. Dry grain under suitable conditions can last much longer. Suddenly, an area containing a high density of energy-rich plants becomes extraordinarily attractive. You don't need to leave immediately. You can stay longer. And this is where a feedback loop begins. Stay longer, and you understand the area more deeply. You know where plants grow best. You harvest more. You manage the landscape. You store more. And once you have storage, you have another reason to stay. Because if you've accumulated hundreds of kilograms of food, moving is no longer simple. You can't carry all of it. Food begins anchoring humans to a location. And once you're anchored, the question changes. It is no longer simply, where do we find food today? It becomes, how do we make more food appear right here? That's a small change in the question, but eventually it changes the planet. Before there were fields, humans were already changing plants. Imagine a group returning to the same area year after year. Every season, they harvest seeds, but not every seed is the same. Some are larger, some are easier to harvest, some remain on the plant longer, some fall to the ground earlier. You don't understand genetics, but your behavior can still create selection. Suppose you preferentially harvest plants that hold their seeds firmly on the stalk. Later, some of those seeds fall near areas where humans are active, or they are deliberately sown. Across many generations, traits that are advantageous to humans may become more common. This is what's important about domestication. It doesn't necessarily begin with a conscious plan. We're going to create a new species of wheat. No one needs to know that genes exist. Selection can happen simply because humans repeatedly create the same pressure. Archaeobotanical evidence allows researchers to track morphological changes in certain domesticated plants over time. In cereals, one famous change involves the rachis. In wild forms, the structure that helps seeds disperse naturally can break easily when mature. That's good for the plant. The seeds fall, they reproduce, but it isn't convenient for humans trying to harvest them. Forms with less brittle rachises keep their seeds attached to the plant longer. They're easier to harvest, and if humans accidentally or deliberately favor them, selection begins. After many generations, the crop becomes different from its wild ancestors. But something strange happens as well. Humans are domesticating the plant, and the plant, in a sense, begins domesticating humans too. Because the plant needs you to work, prepare the soil, sow, protect, harvest, process, store. You have to adjust the rhythm of your life around its cycle. A hunter-gatherer can switch food sources when one source fails. A farmer who depends heavily on a crop cannot easily say, the wheat isn't doing well this year. Let's leave. The field is here. The food store is here. The house is here. Months of labor are here. You have invested in the location. And investment creates dependence. This is one of agriculture's great paradoxes. You can produce more calories on a given area of land, but in exchange, you must devote more of your life to that very piece of land. Yet why would humans accept that trade-off? Perhaps the answer lies in one very simple factor. Not how much food each individual has, but how many people a piece of land can support. It only had to support more people. Imagine two identical areas of land. In the first, a small group of hunter-gatherers lives on wild food resources. In the second, a community grows calorie-rich crops. The question people often ask is who lives better, but evolution and history don't necessarily reward the group with more leisure time. Another question may matter more. Who can maintain a larger population on the same amount of land? Agriculture can create a high density of calories under suitable conditions. A cereal field can concentrate a large quantity of carbohydrates into a relatively small space. The food can be harvested, stored, distributed, and this supports higher population densities. This is the game-changing point. A hunter-gatherer family needs enough space to exploit dispersed resources. If the population grows too large, pressure on those resources increases. Farming can increase the amount of food extracted from a given area, but the price is labor. You have to sow, weed, protect, harvest, grind, process. Some bioarchaeological studies suggest that the transition to agriculture in many regions was accompanied by adverse changes in health among certain populations, although the pattern varies greatly depending on place and period. Diets could become more dependent on a few staple crops. Dental caries could increase in some contexts. Signs of physiological stress could change. Infectious diseases became more important as population density increased. In other words, agriculture wasn't necessarily a simple upgrade for each individual, but it had another advantage. It could create more people. And when a larger farming community appeared beside a smaller group, the balance changed. More people meant more labor, more people to defend territory, more children growing into adults, a greater ability to expand into other lands. A system doesn't have to make every individual happier in order to spread. It only has to reproduce itself faster than the competing system. But why did the population increase? Part of the answer may lie in a change that seems almost unrelated to food. The interval between births. Why could settlement change the rate of population growth? Imagine you have a 2-year-old child. The child cannot travel far yet, but your group has to move. Not a few hundred meters, many kilometers. You carry the child, carry food, carry tools, carry necessary materials. Then, a few months later, you move again. In a highly mobile society, young children create a very real limitation. They need care. They need to be carried. And every dependent child increases the cost of movement. But now, change the setting. You no longer move frequently. You live in a settlement. There is long-term shelter. There is stored food. There are tools kept in one location. There are other people living nearby. The child doesn't have to be carried for dozens of kilometers every time resources change. And that can contribute to a change in one extraordinarily important factor: the interval between births. Anthropologists have proposed that reduced mobility, changes in diet workload, and many other ecological and social factors may have contributed to changes in fertility as communities became more sedentary. There is no single cause, but archaeological demography suggests that in many regions, periods of population growth emerged in association with the transition toward Neolithic lifeways, and that creates another feedback loop. More food per unit of land allows more people to live close together, more people to create more labor. More labor can expand the area under production. More production supports a larger population. Population growth then makes a complete return to a mobile way of life more difficult. Imagine a community of 50 people. If wild foods decline, they can split into smaller groups, move, try another region. But what if the settlement already contains 500 people? You can't simply tell everyone the herds are gone, we're leaving. 500 people require an enormous number of calories, and landscapes suitable for a small group of foragers cannot necessarily absorb hundreds of new arrivals. This is where agriculture begins to resemble a strange kind of trap. You need farming to feed the population, but that population exists. Because of farming, it becomes difficult to know which is the cause and which is the effect. They pull each other forward, and every generation born in the settlement knows less about a completely mobile world. For their grandparents, farming may once have been a new strategy. For them, it's simply life. You can point to it. This belongs to us. And when something can be accumulated, it can also be inherited. Parents die, but the land remains. The storage remains. The livestock remains. One generation can begin life with more resources than another. That is the seed of a problem that will later become enormous: inequality. But before agriculture created kings, it created something far less dramatic, and perhaps more dangerous in everyday life: waste. When staying in one place makes the living environment dangerous, you wake up in the settlement. People are all around you, more than you would ever have seen in a small hunter-gatherer group. Children run between the houses. Food is being processed. Animals live nearby. There is water, there is grain, there is life. But there is also feces, food waste, animal carcasses, wastewater, insects, rodents, and a great many human bodies living close together. Mobility has one advantage that is often overlooked. When a group leaves a location, they also leave behind some of the waste that has accumulated there. But a settlement cannot simply walk away. If humans remain for months and then years, waste management becomes a problem. And when domesticated animals live close to humans, a new ecological interface appears. Humans, animals, pathogens, all sharing the same space. This doesn't mean that every epidemic in history appeared immediately with agriculture. Disease ecology is far more complex than that. Some diseases have histories older than farming, and different pathogens have different origins. But current research indicates that increasing population density, sedentism, and frequent contact with animals created new conditions for the transmission and evolution of many infectious diseases. A pathogen needs a host. If a group consists of only a few dozen people and frequently disperses, some chains of transmission are difficult to sustain for long. But when hundreds and then thousands of people live close together, the mathematics changes. One person can infect more people. The pathogen gains access to more hosts. Settlement connects to settlement. Later, trade routes expand the network. Humans create ecological highways for disease. And agriculture brings another problem. The diet can become less diverse. Imagine a forager using dozens of seasonal foods. Now imagine a farmer receiving most of their calories from one or a few staple crops. Calorie supply may become more stable, but diversity may decline. Bioarchaeological evidence from many regions suggests that the transition to agriculture was sometimes accompanied by changes in stature, dental health indicators of anemia, or other signs of physiological stress. But the pattern is not the same everywhere. There was no single agricultural health collapse that happened to all of humanity. Location, crop, environment, social organization, all of them matter. Yet the paradox remains. If farming could bring workload, disease, dietary risk, and dependence, why didn't it disappear? Why didn't farmers simply look at the lives of foragers and say, "We made a mistake. Let's go back"? Because at a certain point, going back was no longer simple. When agriculture was no longer a choice, imagine 3 generations. The first generation still knows very well how to live from wild resources. They know the migration routes, they know hundreds of plant species, they know the best hunting areas. Farming is only one part of their strategy. The second generation grows up around the settlement. They still hunt, still gather, but spend more time on crops. The third generation is born into a large community. The population has grown, the surrounding landscape has changed, some areas have been cleared, plant species are being managed, wild animal populations may face additional hunting pressure, and now, tell them abandon farming. What will they eat? This is the crucial point. A region that once supported a small population through foraging cannot necessarily support a much larger population if everyone suddenly returns to the old system. You cannot gently reduce the population to match the old carrying capacity, and you cannot restore lost ecological knowledge in a single morning. Path dependence begins to appear. One decision changes the conditions of the next decision. You grow more food, the population increases. Because the population increases, you have to grow more food. You clear more land. Because the landscape changes, foraging becomes different. You build storage. Because storage now exists. You have to protect it. You settle down. Because you've settled, you have more children and possessions that are difficult to move. Each step makes the previous step harder to reverse. No one has to plan the final outcome. No one has to say, "We're going to create civilization." Each generation simply solves the problem in front of it. More food, more storage, more land, more people. But when all those small decisions accumulate, an entirely new world appears. And that world requires organization. Because a community of a few dozen people may resolve disputes through direct relationships. But what about a settlement of thousands? You don't know everyone. Not everyone is related to you. Not everyone trusts one another. Who distributes the water? Who protects the grain? Who decides land boundaries? Who resolves disputes? Who organizes labor? Who protects the community from other groups? This is where food production begins turning into politics. Surplus doesn't just feed people, it can feed power. Imagine a grain store. Very large, larger than what a single family needs. It represents thousands of hours of labor, sowing, tending, harvesting, transporting, processing. And now, all that energy is sitting inside one room. A person who controls that room controls what, not only food, they may control other people's survival time during periods of scarcity. This is why surplus matters. A person who has to spend all their time obtaining food cannot spend the entire day doing something else. But if farmers create enough surplus to support people who don't directly produce food, specialization becomes more possible. Craft specialists, builders, traders, administrators, religious specialists, and later, soldiers. Not all of these roles appeared the moment farming began. The process took thousands of years and varied greatly between regions. But surplus created the material conditions for specialization, and specialization can increase complexity. Someone who makes tools all day can become better at it. Someone who manages irrigation can accumulate specialized knowledge. Someone who records quantities of grain can eventually contribute to systems of accounting. In some ancient civilizations, the need to manage resources, taxation, and exchange was deeply connected to the development of writing and bureaucracy. Look at the chain of change: seed, field, harvest, surplus, storage, accounting, authority, state. Not an inevitable straight line. Not every farming society creates an empire. But agriculture helped create conditions that were previously difficult to sustain on a similar scale. And power creates another paradox. Surplus can protect a community from famine. But if distribution is unequal, surplus can also exist right beside hunger. From this point onward, humans begin living in a strange world. A world in which starvation no longer happens only because nature fails to produce enough food. It can also happen because humans control access to food, and that is a profound turning point. In the foraging world, the main challenge is finding resources scattered across the landscape. In complex agricultural societies, you can stand only a few meters from a storehouse filled with grain and still have no right to eat it. But before large kingdoms appeared, something else had already begun changing in those first fields. Not only human society, but evolution itself. Because while we were changing wheat, cattle, goats, rice, maize, those species were also changing us. And within only a few thousand years, the human body began carrying traces of a way of life that hunter-gatherer ancestors had never known. Agriculture didn't just change the world, it began changing us. Imagine a child born in an agricultural settlement. That child has never known the world that came before. To them, grain isn't an invention. The field isn't a technology. Animals living beside humans aren't strange. That's simply the world. The child grows up, eats foods different from those of their more distant ancestors, encounters different pathogens, lives close to more people, performs different kinds of work, and if those conditions persist for long enough, they don't merely change culture, they create new selection pressures. One famous example can be found in a glass of milk. Most mammals produce the enzyme lactase when young in order to digest lactose in milk. In many humans, lactase production decreases after weaning. But in some populations with long histories of pastoralism, genetic variants associated with lactase persistence became common. Adults could continue digesting lactose more effectively. This is a powerful example of gene-culture coevolution. Culture changes the environment. Humans begin raising livestock and consuming milk. The new nutritional environment gives an advantage to certain genetic variants. Those variants spread. Culture changes genes. Genes, in turn, influence how culture can develop. But milk is only one part of the story. Agriculture changed the things humans encountered every day: starch, pathogens, animal products, population density, food processing. All of these created a new evolutionary environment. Current research indicates that many genes in human populations underwent selection during the Holocene in relation to diet immunity and other ecological changes. This overturns a common misconception that human evolution somehow stopped when civilization began. It didn't. Evolution doesn't care whether you live in a cave or a city. If there is variation, inheritance, and differences in reproductive success, selection can still occur. Agriculture didn't remove humans from evolution. It created a new evolutionary playing field. But the changes didn't occur only in genes. They appeared in skeletons, teeth, muscles, signs of stress. Bioarchaeologists can examine skeletal remains and look for clues about workload, disease, and nutrition. In some agricultural communities, teeth begin to tell a different story. Carbohydrate-rich foods and food processing practices can contribute to changes in patterns of dental disease. Cavities become more common in many farming populations, although the extent varies according to diet and context. Bones can also reflect changes in physical activity. A hunter-gatherer moves across the landscape differently from a farmer who repeatedly performs activities related to plowing, digging, grinding, or carrying loads. The body records life, not in words, but in wear, stress, growth, injury, disease. And when archaeologists read those traces, an interesting truth emerges. Technological progress does not necessarily mean an immediate improvement in the human body. Society can gain certain things, while individuals pay the price. But if agriculture carried costs like these, it must have offered something powerful enough to keep the system expanding. Part of the answer lies in population, part in storage, part in territorial expansion. But there is another factor, something humans had feared long before farming: the hungry season. A field is a promise that you may still be alive months from now. You hold a seed. It's so small that it seems almost insignificant. You could eat it, but instead, you bury it. From a survival perspective, that's a strange thing to do. You're giving up calories right now in exchange for the possibility of having more calories in the future. There are no guarantees. The rain may not come. Insects may destroy the crop. Animals may eat it. Fungal disease may spread. A flood may erase months of labor. Another group may take the harvest. Farming doesn't eliminate uncertainty. It changes the shape of uncertainty. Hunter-gatherers often face dispersed fluctuations. Today's hunt fails, but tomorrow's may succeed. One source of fruit disappears, but another appears. Agriculture can create a more concentrated form of risk. You invest months in a harvest. If it succeeds, the amount of food can be enormous. If it fails, the entire community faces the problem together. That's why storage becomes so important. A good year can help protect against a bad year. If grain can be preserved, last season's surplus becomes insurance for the next. And the more humans depend on farming, the better they have to become at thinking about the future. When should we sow? How many seeds should we keep? How much can we eat? How much must be reserved as seed? When does the rain usually arrive? Is there enough storage? If the population grows, how much more land will we need if winter lasts longer? Will the surplus be enough? Calendars become important. Not necessarily written calendars, but the ability to track seasons, the moon, the Sunday animal behavior, plant cycles. Farming turns time into part of production. You can't sow whenever you want. You can't harvest whenever you feel like it. If you miss the window, the entire year can change. So farmers don't only domesticate plants, they begin domesticating the schedule of their own lives. Planting season, harvest season, storage season, repair season, the breeding seasons of livestock. Life becomes increasingly divided by recurring tasks. Perhaps this is one of the deep origins of the way we live by schedules today. Agriculture didn't invent the clock, but it increased the value of coordinating behavior with precise cycles of time. And when many people have to work together, coordination becomes more important. One person may be able to hunt a small animal, but an irrigation system, a wall, a large harvest that has to be completed before the rain, that may require the entire community. And when hundreds of people have to coordinate, a new question appears. Who organizes them? But it changed what humans could build. There is a very compelling story. It goes like this. Humans invent farming, then they build villages. Villages become cities. Cities create kings. Kings create civilization. Neat, simple, and far too simple. Archaeology today shows that the paths toward social complexity were highly diverse. Some hunter-gatherer societies displayed significant levels of sedentism and social complexity. Some farming communities existed for very long periods without becoming states. Some monumental structures appeared in contexts that make the model of farming first civilization later far more complicated. Göbekli Tepe is a famous example. The monumental structures there were built by communities living through a complex transition between foraging and food production, forcing researchers to rethink simple relationships between agriculture, sedentism, ritual, and large-scale cooperation. Perhaps ritual encouraged people to gather. Perhaps large gatherings increased the demand for food production. Perhaps food production supported ritual. The causal relationship doesn't necessarily run in only one direction. That's the important point. History rarely works like dominoes. One piece falls, then the next. It's more like a network of feedback loops. Food production affects population. Population affects cooperation. Cooperation affects landscape management. Landscape management affects food production. Storage affects settlement. Settlement affects fertility. Fertility affects population. Population then places additional pressure on the food supply. No single person controls the entire process, but the system still moves. Across thousands of years, some settlements become larger. Division of labor increases. Trade networks expand. Storage develops. Leadership becomes more formal in some places. Eventually, societies containing tens of thousands of people emerge. Then, hundreds of thousands. A hunter-gatherer band depends largely on direct relationships. You know the people around you. But cities create an entirely new cognitive problem. You have to live beside strangers, thousands of people you've never met, and you still have to cooperate. That requires new social technologies, rules, institutions, shared identities, religion, markets, authority, law, records. Not all of these were created by agriculture, but food surplus and population density helped create environments in which they could develop at unprecedented scales. And from one small seed, we eventually get bureaucracy, taxation, armies, writing, cities, states, empires. But return to the original question. Why? If hunting and gathering worked, why did farming win? Perhaps win is the wrong word. Perhaps humanity never made a single decision at all. Imagine you're living during the transition. You don't know you're living through the Neolithic Revolution. There is no historian standing beside you saying, this is the moment civilization changes. You only have this year's problems. There are more people. You need more food. So you plant more. The following year, the population is larger again. You clear more land. You build larger storage facilities. A dry season arrives. The group depends more heavily on stored grain. Then you have more children. The settlement expands. One generation passes, then another. No one ever stands in front of two doors, labeled hunter, gatherer, and farmer, and chooses one. Change may happen centimeter by centimeter. A little more plant management. A little more sedentism. A little more storage. A little more domestication. One more child. One more house. One more field. By the time someone realizes the world has changed, there may no longer be a simple path back. This is how many of history's greatest transformations happen. Not because people can see the final outcome, but because each small decision makes sense in the moment. And the sum of reasonable decisions can create a world that no individual ever planned. Agriculture may not have begun because it was better. It may have expanded because, under certain conditions, it produced more food from a given area, supported larger populations, allowed storage, created settlements. And once populations grew large enough, the system reinforced itself. Farming fed people, people created more farming, both grew together. Eventually, a species that once followed animal herds began waiting for wheat to grow. A species that once read footprints began reading the seasons. A species that once carried most of its possessions on its body began building storehouses, walls, houses, villages, then cities. We didn't only domesticate plants, we domesticated the landscape. Then the landscape domesticated us in return. Return to the handful of seeds from the beginning of the story. You're hungry. You could eat them all, but you save some, place them into the ground, cover them with soil, and wait. No loud sound, no flash of lightning, no revolution, just a seed disappearing beneath the earth. But that action contains a very special idea tomorrow can be designed. Hunter-gatherers also planned for the future. They stored food, followed seasonal cycles, managed landscapes, remembered migration routes. So foresight did not begin with farming, but agriculture brought the attempt to control the future to a new scale. Instead of asking only where will food appear, Humans increasingly began asking, how can we make food appear here? That is a profound philosophical shift. Nature is no longer only something to be read, it becomes something that can be edited. We select plants, move water, clear land, breed animals, protect crops, remove competing species, and across thousands of years, the entire planet begins carrying the marks of human choices. But the price is also enormous. Labor, disease, conflict over land, inequality, dependence, famine when harvests fail. There is no simple story of progress. Agriculture solves problems while creating entirely new ones. Perhaps that is what makes this story so deeply human. We invent a solution. The solution changes the world. The new world creates new problems. And then we have to invent again. The seed leads to the field. The field leads to the village. The village leads to storage. Storage leads to wealth. Wealth leads to power. Power leads to societies more complex than anything our distant ancestors had ever known. And thousands of years later, most of us no longer know how to live without that system. You may never have planted wheat, never hunted an animal, never searched for a wild tuber. But every morning, you still live inside the consequences of decisions that began thousands of years ago. Bread, rice, maize, milk, meat from livestock, cities, jobs, money, property, government. All of them have deep connections to the world that food production helped create. Perhaps the final question isn't, why did humans start farming, but when did farming begin changing what it meant to be human? Because from the moment we placed the future into the ground, we weren't only growing food. In a sense, we began growing the modern world. A field filled with grain, a large settlement, storehouses filled with food, everything seems safe. Then the rain doesn't come. 1 week, 1 month, the crops begin to dry. The elders look toward the sky. The storehouse is opened. Grain is distributed. But the population is now larger than any hunter-gatherer band. Hundreds of people depend on the same harvest, and they cannot simply walk away. The houses are here. The land is here. The children are here. The stores are here. Their entire lives are here. That is agriculture's final paradox. It helped humans produce more food, but it could also make enormous numbers of people depend on the same source of food. So what happens when that source fails? How did humans survive the first great famines? What did they eat when the grain disappeared? Did they abandon their villages, fight their neighbors, sell their possessions, eat the seed grain meant for the following year? And what happens when hunger lasts not for a few days, but for years? That's our next story. How did ancient humans survive the worst famines in history? Because after humans learned how to create surplus, we also created something new. A world in which thousands of people could go hungry at the same time.